Hello everybody, welcome back to the last session of the Food Packaging Technology course. We are in the week 8 and the last session for this week is the packaging printing machines. Last few days we had been going through the different packaging machineries like the retort pouches, bottling machines, the carton machines, and in the last class we talked on the first part of the package printing machines. To continue with the same topic, we had gone through the different conventional methods. The first one we talked to was of the relief methods. We'll go on to the next method, which is the gravure or the intaglio method. Now, the gravure printing was also known as the intaglio method from the Italian word which means incising or engraving. This technique was actually first used or practiced in Florence in 1446 by goldsmiths and engraver Finigura. So here usually it's also known as a rotary gravure printing because here, unlike a relief method which uses plates, they use rotary or cylinders as your printing press. This consists of a printing cylinder which is actually the image carrier. Number 2, you will have an impression cylinder which impresses the engraving onto your substrate. And third, you have, as all printing machines, you will have an inking system. Now, the printing cylinder that you have is usually made of chrome-plated copper surface, and here the image that you have to print is etched in a form of small cells. Okay? It has varying depths and that picks up the ink from the inking system. During printing, the image carrier is immersed first in the fluid ink, and then the image carrier will rotate, the ink fills into the tiny cells and it covers the cylinder. There is a doctor blade which washes out or wipes out the excess ink from the non-image surface of the cylinder. As the cylinder comes in contact with the impression cylinder, it presses the material in contact with the cells and the impression is made onto the substrate. So this is actually a high quality printing method compared to your relief method. So this is a pictographic representation of a rotogravure printing. Here you have the engraved cylinder. You can see the engravings, which is A, and this rotates through the ink. The doctor blade B will remove the excess ink, but the etched recesses, the etched ones, the remaining ink is then impressed onto your packaging material by the cylinder C, which is the rubber impression of the cylinder. Now, just like your flexographic printing, the gravure printing, you can do it on a wide variety of materials, including printing of cartons, films, foils, papers. Okay? The ideal substrate that you have is usually smooth. You have clay coated, supercalendered films or for papers or foils, because effective ink transfer will depend on thorough cell contact with the substrate. So, the cell has to come in contact with the substrate. Here it's recognized as an entire image area is usually dipped into the ink and used for printing. So you have a better quality, like I said, and the preparation is usually more costly and time consuming. So it's usually economical only in long printing runs. If it's for smaller amounts, it's usually not very economical, but for larger production runs, the gravure printing is actually good. The printing speeds are slower than that you get in the flexographic processes. But despite all this, the gravure printing is a high quality, multicolor, fine detail printing. So we went through the relief, again divided into the letterpress, flexography and the flexo process. Second process we saw was the gravure printing, and the third we'll go on is the offset lithography. The offset lithography printing is also known as offset lithography. Okay? This was actually invented by the Austrian artist in 1798. He wanted to print, musical scores more cheaply by engraving. So here what happens is a print of a drawing is done on a stone, and the stone is usually limestone that is done. And for 100 years, lithography is used in print packaging. It's also used in cards, menus, book illustration, and it's the major form of printing even today. You print on a flat surface. The image area is neither raised, it's raised in a letterpress and a flexograph, nor is it lowered like in a gravure. So it's just a flat surface on a stone. It is based on the principle that oil and water does not mix together. So what they do is they have oil-based inks, and that is applied through a series of rollers to the offset plate cylinder. Okay, and then water is simultaneously fed through the rollers to the plate just before it enters into the, or it makes contact with the inking rollers. Okay, that helps in making the impressions. So this is a picture of that. You have the offset lithography. The image, as you can see, it's neither raised nor is it lowered, and it's based on the principle that oil and water does not mix. The plate A, this is the plate cylinder, B is the offset blanket, and C is the impression cylinder. The material will go through the offset blanket cylinder and the impression cylinders, and the image is etched onto the substrate. What happens here is the image of on the plate, it is first transferred to an intermediate blanket cylinder that you can see B, that is covered with a rubber blanket, and the material to be printed picks up the image as it passes between the blanket and the impression cylinder, which is the B and the C. The soft blanket will create a smooth, sharp image. Unlike the other things, this is a very smooth, sharp image, and you can do it on a wide variety of materials, especially used where illustration is required on packaging materials. You have pictures and illustrations, this is very useful. Offset lithography produces quality printing on both rough and smooth papers, but coated paper is most often used because they use less ink and they give more brilliant colors. It is also used for printing labels and cartons and for decorating metal containers. It is much cheaper than your rotogravures, and it can be used to deliver gravure equivalent print quality, though it's much cheaper. So I think you got an idea right now. We went through the relief methods, the gravure method, the offset lithography, and the last is the screen or the porous printing. Now, the screen printing also is known as the porous printing method. It's actually a stenciling process, and there they use fine mesh which is made of silk or polyester, or even metals are used, and that is supported by a stencil. Ink is first forced onto the screen by a rubber blade. You have a squeegee, and this ink can be either solvent, oil, rubber, water-based. But usually drying oil type is used. Okay, they have usually thick also. This paint is thick. It needs more drying time. Now, screen printing is versatile. You can use it on different types of materials, wide variety of materials, including round or irregular. It need not be flat. Your substrate need not be flat. You can have it round or irregular. For example, milk or soft drink bottles. So this is generally ideal for short-run productions, and it's used for imaging glass, box wraps, folding cartons, but it's low speed and the time required to dry is also much more. This is a picture of a screen printing where you have the stencil, the squeegee ink is passed through it, and the image on that stencil is made onto your substrate. This is another picture where you have the same thing represented in a different manner. So with that, we have completed the conventional printing methods, which was the relief methods, which was again divided into the letterpress, flexography, and the flexo process, the gravure method, offset lithography, and the screen printing. We'll now move on to digital printing, which is quite different from your conventional method. Now, in digital printing, the printing is from a digital source directly to a variety of substrate. Okay? And this is for large volume laser or inkjet printers or electrography. Here, unlike your conventional method, they do not use any physical master. That is, they do not have any printing cylinder or printing plates here, because all the graphical content is in the digital form. So the benefit is, number one, consecutive copies can be different from each other. So you can actually personalize or customize for different types. That is not really possible in your conventional method. Secondly, the printing process is much faster and simpler compared to the traditional printing because of elimination of master production. In the other cases, in your conventional method, the master type cylinders or plate, they had to first be etched, then the printing had to be done. This is not needed here, which makes it much more feasible. Like I said, the digital printing was first divided into the inkjet printing. Now, we are all familiar with the inkjet printing. This is an impactless printing. Impactless is there is no contact between the substrate and the inking. It's also known as pressureless printing process, in which the tiny drops of the inks is directly projected onto the surface. You don't have to push it onto or engrave it onto or press it onto it. It's just dropped directly onto the surface for printing without physical contact between the printing device and the substrate. So each drop is controlled electronically. Each drop that you fill or pass on to the substrate is controlled electronically. And that's why it's known as impactless, because there's no mechanical pressure, impact pressure, to transfer the ink to the receiving substrate. And so there is no platen required to support the receiving substrate also. This can be used to print on cans, bottles and objects and other objects also. Two main methods are you have either continuous or the drop on demand. So basically the ink, by non-contact, it is passed on to the substrate. This passing on can either be continuous or drop on demand. So in drop on demand, it is a software that directs the head to apply 0 to 8 drops of ink per dot. So each dot you will add 0 to 8 dots wherever it's needed. So the drop on demand is again divided into the piezoelectric and the thermal drop on demand. In piezoelectric, like the name suggests, the droplets are formed when an electrical signal causes the piezoelectric crystals to expand, and this creates a pressure wave, and that forces the droplets onto the substrate. While on the other hand, the thermal drop on demand inkjet, it's also known as the bubble jet. It works in the same manner, except that the pressure wave that is generated, it's by heat. And that vaporizes a small quantity of ink, and that causes a large pressure increase, and it makes the droplet of ink fall onto the substrate. So mostly they use the piezoelectric print heads in the inkjet printers. The other type other than the drop on demand was the continuous inkjet technique. Here the ink droplets are continuously generated by pumping liquid ink into the chamber, and at high pressure, acoustic pressure waves, using the piezoelectric, they are moved onto the substrate. Here they require higher volume and medium quality, and this is usually used for marking and coding of products and packaging. This is a pictographic representation of the inkjet printers where the printing device has no contact with the paper. The ink is dropped from 0 to 8 drops per dropping, and it is controlled either by electricity or by heat. Another pictographic representation of the inkjet printing. Okay, so we have now on the inkjet printing of the digital printing, and the second one is called the electrography method. Now in the electrography method, it's one of the oldest non-impact printing technologies that was invented by Chester Carlson in his New York laboratory. This is also referred to as xerography, which is one of the most common methods that is used nowadays, or laser printing. So electrography is also very well commonly known as laser printing. And that is specific light exposure technology is used in the process. The electrography method is used in copy machines, laser and LED printers, and it's one of the most complex digital printing technology that is available today. It is a plateless printing technology. It's based on image carrier surface that is electroconductive, which is very important. Here there is no etching, neither is there any ink droplets. Here the carrier surface is photoconductive and it can be charged electrically. In this method, you use a laser or an LED, and a negative of the image is beamed onto the drum, cancelling the charge and leaving a positive replica of the original image. In this method, using a laser or LED, a negative of the image is actually beamed onto the drum, cancelling the charge and leaving a positive charged replica of the original image. Okay, this is much quicker and an economical method. So this is a pictographic representation of a digital electrography. Unlike all the other methods, the quality of the image is high enough and it's used for packaging. The advantage is possibility of using variable data, on-demand manufacturing, much cost effective and within the short runs. Okay, but there are a few limitations that include smaller color gamut compared to the traditional method, format size, productivity. Traditional period you could use a number of different substrates. That is much less in this electrography method. So since the mid-1980s, the color EP printing has been very popular by businesses, and it has been used in almost all fields. Coming to the last method, which is the hot die stamping and the gold blocking. Here the print dies are raised but there is no ink receptive area. Like your letterpress, you have this raised areas, but you don't have an ink receptive area. The carrier is usually a plastic like polyester, and that is coated with a foil or a pigment. And under pressure, you can transfer it to another surface. Advantage is there is no drying or surface penetration, quick for color changes, and there is no cleaning down. The plates may be of silicone rubber, and soft plates is important. That soft plates are usually used for kiss transfer. They just transfer it or make an impression on another material. And metal plates are used. They can give a distinct impression. It may be clear from the picture that is shown. You can either make an impression here in a hot stamping, or you can have by kiss transfer, you can transfer it to the material or the substrate. The metallic foil consists of, there is a carrier, there is a release coating, a lacquer, metallized layer which is deposited by a vacuum, and a hot melt type adhesive. The carrier that you have is either glassine, cellulose film, or the polyester. You can do it in any of these packaging materials, while PET or polyester is the most common base that is used in hot stamping. Now let's look at the important factors that influence the choice of the printing process. Number one, it is the material that has to be printed, whether it is a metal, or glass, or paper, or board. That determines the process. The quality of the print that you require, the quantity that you require to be printed, the form in which you want the printing material, and number five, special requirements like potential toxicity, rub resistance, freedom from odor. All this will determine what kind of printing process you will use or choose from the ones that were mentioned till now. So we'll conclude. We went through different printing methods, both conventional and digital. Conventional, we went for the relief methods, the gravure, offset, and the screen methods. Digital, we went through both the inkjet and the electrography method. Inkjet, we talked about drop on demand and the continuous method. So with that, we have completed the last week course, and we have come to the end of the food packaging technology course. Really wish that you have enjoyed the course. We went through different topics in the different modules. In module 1, we talked about the different materials that were used, paper, the plastics, metals, and glass, how these are made, what are their properties. We went on to talk about how the different forms of packages can be made and the application of this in different food systems, whether it's vegetables or meat or fish products, cereal products. In module 3, we went on to talk about different tests and the transposeworthiness tests that were done and different machineries that were used in the packaging industries. So I think with that, you'll have a fairly good idea of the different aspects of food packaging, which will be very useful in the future too. You'll have your exams coming up in the forthcoming weeks. I wish you all the best in everything. Thank you once again for attending this class and participating wholeheartedly.